Now you're ready to tackle the second part of the lab, which is going to be all about finding the standard error and then calculating z-scores in Excel for the sample mean. And then you can use those z-scores to find probabilities in your unit normal table. Now, unfortunately, Microsoft Excel doesn't really have an automatic function for finding z-scores for sample means, so we have to do this in a somewhat manual way, but it's still easier to do it in Excel than it is to do it by hand, especially with a sample size this large, because we have to calculate the standard deviation, and that would be a pain doing this by hand. So let me show you how to do this in Excel. So the first one, we want to find the standard error for a sample size of 5 from this population. So I'm going to go ahead and just write down here, put standard error n equals 5. Before I can find the standard error for a sample size of 5, I need to find the population standard deviation. So if you remember, the formula for the standard error is the standard deviation for the population divided by the square root of the sample size. And we're not going to use the finite population correction factor for this because we are sampling with replacement. And even if we weren't, our sample size is much, much, much smaller than the population size. So we don't need to worry about that finite correction factor. So just plain old population standard deviation divided by the square root of n. So let's find the population standard deviation. This is our population. I'm just going to abbreviate this SD for standard deviation. And type equals ST, and you'll see STDEV.P, standard deviation for the population. So let's double click that and highlight all of our data, not including the mean. So highlight this one, scroll up, and highlight this one at the top. Hit enter. This is the standard deviation for our population of clients. Now we have everything we need, almost, to calculate the standard error. We've got our numerator, standard deviation, but we need to get our denominator, which is the square root of n. And I've found that it's actually easier to calculate the square root of n by itself in Excel and not just try to incorporate it into the formula. So let's do that right here. So equals SQ. You'll see this little squirt pop up, square root, double click it, and our sample size is 5. Hit enter, and that is the square root of 5. Now we have everything we need for the standard error. So equals the standard deviation for the population, which is right here, divided by, so I put a little slash, see a little slash there, the square root of sample size, and that is the standard error for a sample size of 5 from this population. So on average, we would expect that any given mean from 5 people in this population would be about $4,620.39 away from the population mean. So let's go ahead and copy this, Control C, and put it into our lab assignment. Standard error for n equals 5. Control V, keep text only, and let's bold it. Oh, I just moved things around. Let's undo that. And let's bold the answer. Now let's do the same thing, only with a sample size of 10. So we've already got the population standard deviation for the numerator, but we're going to need to find the square root of 10 to put that into the denominator of the formula. So I'm going to go over here and put standard error n equals 10. And here I'm just going to find the square root of the sample size. So equals SQ, square root, 10, enter. And now to find the standard error, so equals the population standard deviation divided by, so a little slash, square root of the sample size, hit enter. Now I'm going to Control C, copy this, and then Control V, paste it into my lab assignment and make it bold. So if you look at this, you'll see that the standard error from the larger sample size is smaller. And that's always going to be the case. If you think about it computationally, the sample size is in the denominator. And if you have a larger denominator and the same numerator, then overall, larger denominator, smaller value. You're dividing by a larger number. Whereas if you have a smaller denominator, you'll have an overall larger value. That's computationally. But conceptually, if you have a larger sample, it's probably going to be more representative of the population. And on average, you're going to expect to see less of a difference between any given sample mean of this size and the population mean. So again, a larger sample, you're going to expect less of error, less differences between the sample mean and the population mean. And this tells you the average sampling error, essentially, to expect between any given sample and any given population mean. So the next one, and you can answer C on your own, is asking for the z-scores for this specific mean of this specific sample size from this population. So I'm going to go ahead and just copy this number to use it as a reference in Excel. And I'll show you how to get z-scores. Even though there's not a really quick and easy push a button and it happens way, I'll show you how to get it in Excel. So let's go ahead and down here where we're still talking about n equals 5, let's do z mean equals, and I'm going to hit Control V to paste that mean that I just copied from my lab assignment. So remember, the formula for a z-score for a sample mean is the sample mean minus the population mean divided by the standard error. So let's do that in here. So equals, I'm just going to type in the sample mean. I found that if you try to paste it from a Word document, it has error message and it's bad. So 48076.70, that's our sample mean, minus our population mean, which we found down here. And let's go ahead and put this in parentheses so that Excel knows we need to calculate that first. So parentheses here and a parentheses here. So in brackets, in other words. And then divide that whole thing by the standard error that we found for this specific sample size from this population. Hit enter. And this tells us that we have a z-score of 1.50 for this sample mean and a sample of 5 from this population. So 1.5, let's just go ahead and type that in. So Control V bold, 1.5. Now let's do the same thing for a sample size of 10. So let's go over here. If we have, what is the z-score for the mean equals for $48,076.70. All right, same formula as before, but now we have a different standard error. So equals 48076.7. Oh, we want to put this in parentheses. Remember, order of operations. We're telling Excel that we want it to solve for the parentheses first. If you don't use the parentheses, it'll take the population mean divided by the standard error, and then it'll subtract that from this. We don't want that. We want to do the parentheses first. So the sample mean minus the population mean in parentheses. Here's our population mean, and then another bracket, divided by the standard error that we calculated. And that gives us a z-score of 2.13. So Control B, 2.13. That is the z-score for this same exact sample mean, only from a smaller sample size. Still coming from the same population, still looking for the z-score for the same sample mean, but now this is coming from a larger population. And you'll see that the z-score is larger when we have the larger sample size. And the reason that that is because, remember, the larger the z-score, the more extreme the sample mean. And this is a more extreme result with a larger sample because it's different from the population mean, and we don't expect the sample mean to be that different from the population mean with larger samples. So this is a more extreme situation. Whereas here, smaller sample, it's really not that extreme because, of course, we would expect to see differences between the sample mean and the population mean. So you can answer this one on your own. And then for number 8, you're going to be using these z-scores that you calculated. So 1.5 for this one, because that's for n equals 5. 2.13 for part B for n equals 10. And thinking about what type of proportion you're being asked for, a tail or a body, you'll locate these z-scores in the unit normal table to then find the correct probabilities or proportions in that table, and then you'll answer this question here. So that gives you everything that you need to know how to do in Excel to use the probability and the distribution of sample means to then use the unit normal table.